So we'll be looking at the laws of thermodynamics, the laws of thermodynamics. But before we look at the laws, let's look at the word thermodynamics. You agree with me that thermo means what? Thermo is talking about what? Heat, right? A form of energy. Dynamics is talking about what? Changes, right? So thermodynamics is talking about the change in form of energy. We are just looking at the conversion of energy from one form to another. That is thermodynamics. Do we understand that? Thermodynamics, we are looking at the changes, conversion, transformation of energy from one form to another. That's thermodynamics. Now, we have some laws of thermodynamics. I will be looking at 3 laws of thermodynamics. Now, the first law of thermodynamics is referred to as the law of conservation of energy. The law of conservation of what? Energy. Now, it states that energy, you know, most times when you are asked to state the first law, all of you will jump to, it states that energy can neither be created nor destroyed, but can be transformed from one form to, it's actually correct. But if you state it this way, is more mature. It says that what? Says that what? The total energy of a system, including that of the surrounding, remains what? Constant. That the total energy of a system, including its surrounding, remains constant. And you agree with me, if you have something like this, if you have a cup of tea, this is what? This is smoke coming out, Abi? That is it. And this is the tea. Now you agree with me, this place is the what? System, right? This cup here, this line of the cup here is the boundary, right? And anything outside this system is what? Surrounding. Now the first law of thermodynamics is stating that the total energy of this system and the surrounding at any given point remains what? Constant. That is to say that energy can neither be created nor destroyed, but can be transformed from one form to another. Meaning heat energy can be transformed to another form of energy. Electrical energy can be converted to heat energy. Chemical energy can be converted to mechanical energy. But energy cannot be created nor destroyed. Do you understand that? That's the first law of thermodynamics. And the first law of thermodynamics, we say, is the law of conservation of what? Energy. Now the second, so if you are stating it, please, don't just jump to energy can neither be created nor destroyed, because that is more of the conventional definition everybody will give. So by the time they see your own stating that, the first law of thermodynamics states that the energy, the total energy in a system and the surrounding remains constant. That is to say that energy can neither be created nor destroyed, but can be converted from one form to another. The person as is reading will be nodding head like this. Knows your work is different from others, and you get a different mark from others too. So that's the first law of thermodynamics. The second law of thermodynamics. The second law of thermodynamics states that entropy is always on the increase. Read what I wrote there for you. That for every spontaneous change, any spontaneous process, any spontaneous reaction, that there is always an increase in what? Entropy. We know increase, like when we talk about entropy, entropy is level of disorderliness, right? Or randomness. Now, for every spontaneous process, entropy is always increasing. The level of disorderliness, the level of randomness is always on the increase. That is the second law of thermodynamics. That for every spontaneous process, entropy is always what? Increasing. Entropy is always increasing. Now, the third law is sometimes called the zeroth law of thermodynamics. Sometimes called the zeroth law. And you know, the third law states that for a perfect crystal or perfectly crystalline substance, that the entropy is what? Total entropy is what? Zero. That for a perfect crystal, the entropy is zero. Now, let's look at a perfect crystal. Let's look at something like this. Let's look at a solid crystal. You know, the three states of matter, solid, liquid, and gas, which one is more disordered? Gas is more disordered, right? Because the molecules are always moving. But for a perfect crystal, the molecules of a perfect crystal are compact, are together, no movement. So because there is no movement, there is no randomness, there is no disorderliness, we say for every perfect crystal, the total entropy is what? Zero, meaning there is no disorderliness. Do you understand? So the third law of thermodynamics says that for every perfect crystal, the total entropy is what? Zero. The second law of thermodynamics states that for every spontaneous process, entropy is always what? On the increase. The level of disorderliness is always increasing. Then the first law says that what? That the total energy in the system and the surrounding remains what? Constant. That is to say that what? Energy can neither be created nor destroyed, but can be converted from one form to another. So those are the laws of thermodynamics.